Hello students, we will understand today in this class about sol-gel phenomena. Fine. Now in this sol-gel phenomena, first of all we have to think in mind that this is not about sol and gel. Sol and gel here are relative terms where sol means anything which has lower viscosity as compared to gel, and gel is something which has higher viscosity as compared to solution. So gel does not exactly means a gel. It means anything having a higher viscosity than solution. Now we will describe Hello friends, in this video we will understand about sol-gel phenomena and its application in characterizing various types of flow behaviors of fluid. Now sol-gel phenomena, the sol-gel does not represent actually solution and gel. Sol-gel here means they are relative terms where sol means anything which has lower viscosity as compared to gel, and gel means anything which has higher viscosity as compared to sol. So sol and gel are representative terms. They are relative terms where one describes higher viscosity and sol describes lower viscosity. So we now apply this phenomena in all the types of rheological fluids. So first is Newtonian. Newtonian fluids, as we have already discussed, are those fluids whose viscosity remains unchanged on application of stress. This means initially if they are in solution form or sol form, they will remain in sol form, or if they are in gel form, then they remain in gel form after application of stress. So this arrow means or is representative of stress. So on application of stress, their viscosity remains same. There is no change in the viscosity, and such materials are called as Newtonian materials. Now after Newtonian materials, we will discuss about time independent and time dependent materials. First to start with time independent material, and first in the category is plastic materials. Now plastic materials are those again which requires certain amount of shear greater than the yields value in order to flow. So if they are in sol form, they will remain in sol form, but initially there is no movement, and after this stress, which is called as yields value, they again remain in sol form. So they do not have any initial strain value. This is because till this point yields value is greater than the value applied. Once the stress is greater than yields value, their viscosity remains unchanged and possibly they behave like a Newtonian material. In few cases they can also behave like a pseudoplastic material, which I will explain later, and at that time they are called as viscoplastic, another term. This is plastic where they behave like Newtonian after yields value, but if they behave like pseudoplastic after yields value, they are called as viscoplastic. So we switch over to next type of time independent flow. This is called as pseudoplastic. Now pseudoplastic by sol-gel phenomena is a system which are initially in gel form, and on application of stress they come to sol form. This means they are called as shear thinning systems. On application of stress, viscosity decreases. Fine, they are called as pseudoplastic material. See, there are several theories. One theory said that they remain in sol form if stress is removed. When stress is lowered, or they instantaneously come back to gel form. Fine. So two properties: gel is converted into solution, and upon lowering of or removal of stress, they come back instantaneously to gel form. So there is only single curve in their rheogram. Fine. Now we move on to next type, which is called as dilatant system. Now dilatant system or dilatancy, it is also called as shear thickening systems. Means these are the systems whose viscosity increases on application of stress. So initially they are in sol form, they are converted into gel form on application of stress. This is called as dilatancy. Fine. So next we will discuss different types of time dependent materials. There are 4 types of time dependent materials in our syllabus. First is thixotropy, second is antithixotropy, third is rheopexy, and fourth one is negative rheopexy. We will understand them one by one. Now we start with thixotropy systems. Now, thixotropy is somewhat related to pseudoplasticity. Means, thixotropic materials are those which are gel at the start. They are converted to solution or sol form. Fine. Now, gel on application of stress is converted into sol. This is behavior of pseudoplastic material. But in pseudoplasticity, the change is instantaneous, so it is not reflective. But in case of thixotropy, the sol form come back again to gel form after a time lag. So there is lag of time, and after a time lag, it is converted back to gel form. Now, because of this time lag, the curve is not a single line, whereas there are 2 lines in the curve of thixotropic materials and antithixotropic materials, which I will explain. So what is thixotropy? Thixotropy, you can say, is advanced form of pseudoplasticity. Gel is converted to solution. This is pseudoplasticity, and this solution is again converted to gel form after a time lag. Now this complete system or materials which show this type of behavior are called as thixotropic materials. Now we shift over to antithixotropic materials or negative thixotropy, also called as negative thixotropy. Now these are materials which initially represents dilatant systems. So they are initially, their viscosity increases with application of stress, and when stress values are decreased, they regain its original lower value of viscosity again after a time lag. This means they are the systems whose viscosity increases on application of stress, and on slowly removal of stress, they regains or their viscosity again decreases to the original position. But there is always a time lag, so there are 2 curves instead of 1, as in case of dilatant systems. So thixotropy and antithixotropy are nearly same terms with opposite mechanism like pseudoplasticity and dilatancy. Now we move to rheopexy and negative rheopexy. Now rheopexy is associated with thixotropy, whereas negative rheopexy is associated with antithixotropy. Now what is rheopexy? Rheopexy is this sol form is converted to gel. So conversion of sol to gel is enhanced due to slow motions like rolling motion, tumbling motion. So rheopexy is a phenomena where small stress speeden up the conversion of sol to gel. This time lag is reduced, and this phenomena is called as rheopexy. Now, most of the rheopectic systems in few books are also referred to as antithixotropic systems. Both of them are also related. See, in both these cases, sol form is converting into gel with stress. In this also, sol form is converted into gel with stress. Stress is low here, but the important thing is the difference between rheopexy and antithixotropy is that First of all, gel is deforming into the sol form. Fine. Then sol is again reforming. So it is rearrangement into gel form. So rheopexy is basically a rearrangement. So thixotropic systems, when their rearrangement is speeded up, it is called as rheopexy. Whereas antithixotropy is deformation. So under influence of stress, sol is deforming to form a gel. So this is the basic difference. It is deformation. This is rearrangement or reformation. Now what is negative rheopexy? Negative rheopexy is similar to rheopexy, but it is related to antithixotropic systems. So when in any case the sol is converted to gel, as in case of antithixotropic system, and when they are coming back to sol, if we speeden up this process by application of small stress, this is called as negative rheopexy. So negative rheopexy is speeding up of the second phase of antithixotropic systems, whereas rheopexy is speeding up of second phase of thixotropic systems. So in summary, plastic and pseudoplastic materials are related to thixotropy and rheopexy. So plastic, pseudoplastic, thixotropy and rheopexy are one types of materials, whereas dilatancy, antithixotropy and negative rheopexy are one kind of materials. Both them, three of them are related, whereas all four of them, plasticity, pseudoplasticity, thixotropy and rheopexy, they are related.